Hi, let's solve this problem z transform of cos h n theta and z transform of sine h n theta. These two are hyperbolic functions. So what is the formula for cos h n theta? It is e power n theta plus e power minus n theta by 2. And sine h theta is e power n theta minus e power minus n theta by 2. These are the two hyperbolic functions. So first, instead of applying z trans, because we don't have any direct formula for z transform of a hyperbolic function, but we do have formula for exponentials. So e power theta the whole power n, e power n theta I am writing it as e power theta the whole power n plus e power minus theta the whole power n by 2. 1 by 2 we have taken constant. So we know what is z transform of k power n, z by z minus k. Okay, in the place of k we have e power theta, so z by z minus e power theta, and in the second one z by z minus e power minus theta. Okay, now we have to take LCM. So z into this z, actually this is common for both, so we can take it out. So z minus e power minus I theta plus z minus e power theta divided by, now we are multiplying z into z, z square, then minus z e power minus theta, e power minus theta into z, then last one minus of minus will become plus e power theta plus minus theta. We'll add the power, right? When we multiply e power a into e power b, what is the formula? E power a into e power b is e power a plus b. We'll add the power, right? So e power theta plus minus theta, so e power 0, that is 1. So last term became 1. Now we have to simplify these terms. Now this is the answer, but I want the answer in terms of hyperbolic function. So again we are going to simplify to get in terms of hyperbolic function. So z plus z we had 2z, and then we can take minus from these two terms common, e power minus theta plus e power theta. Denominator again we can take minus z common, so e power minus theta plus e power theta plus 1. So this is nothing but 2 cos h theta. Okay, in terms of hyperbolic, what we started from cos h n theta, so here n is equal to 1, so 2 cos h theta divided by z square minus z 2 cos h theta plus 1. Similarly, we can solve the z transform of sine hyperbolic function. It is e power n theta minus e power minus n theta by 2. So z by z minus k, same procedure. And here z, after taking z common, when you cross multiply, one second, yeah, now it's visible. So e power theta the whole power n, so z by z minus k minus z by z minus k, same thing. In the case of first case, k is e power theta, second case k is e power minus theta. And when you cross multiply this z, because of the negative sign, first term will get cancelled, z and z will get cancelled, and we get e power theta minus e power minus theta. This is nothing but sine hyperbolic function. Same thing, we are taking minus z in the common in the denominator, and we are getting this answer. So eventually what we will do is we'll study the basic formulas, and then whatever the problem is, we'll try to simplify it and write it in our formula format, and then we'll apply z transform. Now see this problem, z transform of cos n pi by 2 plus pi by 4. Okay, whenever you see a problem of this type, this is nothing but n pi by 2 plus theta. This theta could be anything, it differs from problem to problem. So immediately we should connect to the formula z transform of cos n theta. Remember, we derived in the last video, this is nothing but z into z minus cos theta by z square minus 2z cos theta plus 1. So no need to start from the beginning to prove this. Okay, so better you can take this formula as it is depending on the mark. If the mark is 7 marks, then you prove only this which is required for it. Okay, so now, but still we cannot apply it directly because we have two terms. So this is nothing but cos a plus b. So cos a plus b formula, we will use it, cos a cos b minus sin a sin b. In the place of a I have pi by 2, in the place of b I have pi by 4. So we get cos n pi by 2 cos pi by 4 minus sin n pi by 2 sin pi by 4. What is the value of cos pi by 4? 1 by root 2. So sin pi by 4, that is 45 also, 1 by root 2. We are taking 1 by root 2 common. and we are getting cos n pi by 2 minus sin n pi by 2. So now we have simplified this. It's easy for us to apply Z transform now. Okay, so applying Z transform on both sides, we get this. Z transform of, this is our question. This is nothing but we are just throwing out the constant 1 by root 2 into Z transform of cos n pi by 2 minus Z transform of sin n pi by 2. Okay, so already we have derived Z transform of cos n theta and Z transform of sin n theta. So remember this derivation, we have multiplied by Z minus e power minus I theta. Here only theta changed. So you can take down this formula as it is depending on the mark, and Z transform of cos n theta is Z into Z minus cos theta by Z square minus 2Z cos theta plus 1, and Z transform of sin n theta is Z sin theta by Z square minus 2Z cos theta plus 1. So we are going to take this formula as it is. So in the place of theta we have pi by 2. So Z into Z minus cos pi by 2 by Z square minus 2Z cos pi by 2 plus 1 minus Z into sin pi by 2 by Z square minus 2Z cos pi by 2 plus 1. So cos pi by 2 value is 0 and sin pi by 2 is 1. So now we have to just simplify the values. Since the denominator is common, we can take this as it is as a common denominator. And if you multiply this Z square minus Z cos pi by 2 minus Z sin pi by 2. Now you can substitute the values for cos pi by 2 and sin pi by 2, and we end up getting Z square minus Z by Z square plus 1 into 1 by root 2. This is the value. And if you see this problem, Z transform of sin 3n plus 5. This is nothing but sin a plus b, and then sin a cos b plus cos a sin b. So sin 3n cos 5 plus cos 3n sin 5. Okay, so this is just a constant, so you can take it out, and Z transform of sin 3n plus sin 5 into Z transform of cos 3n. So now we will be using the formula over here. And one thing, if you notice, we have sin 3n here. Okay, so what is the general formula? Sin n theta. In the place of theta we have 3. So by formula Z sin theta, so I have written Z sin 3 by Z square minus 2Z cos theta, so I have written 3 plus 1. So here theta is 3. Similarly, replacing theta by 3 in this formula also, we got this desired result. In case if there are such problems for 7 marks, then better you can derive the formula for this. Actually we can use the same derivation concept and find it for the particular case, but instead of wasting time in a particular case, you can use the general case formula and derive the derivation over there. So that's easy for us. Actually what I meant is, in the previous problem, if you see in this book, they have derived it directly. They didn't use the formula Z by Z minus e power minus I pi by 2, Z minus cos pi by 2 minus I sin pi by 2, substituted the particular value and multiplying the numerator and denominator by Z plus I, and right hand side we will get this answer, left hand side we will get cos n pi by 2 plus I sin n pi by 2. So if we equate the real part we get this, if we equate the imaginary part we get this. So procedure is the same, okay, but this is a particular case, and we will be using this formula Z transform of cos n pi by 2 and sin n pi by 2 in case of inverse. So please add it to your formula page. So this is a particular case where they multiplied with Z plus I and Z plus I in the numerator and denominator. But what we have done is a general case, Z transform of cos n theta. So better study only that and use that as a formula in all problems. And if you see this tabular column, these are the formulas that we have learned so far. Z transform of 1, Z transform of n, Z by Z minus 1 the whole square, Z transform of n square, n cube, and so on. So if I know this, then I can guess Z transform of k power n. I can guess Z transform of k power n into n. Just this formula is similar, kz by z minus k the whole square. Okay, and then we have shifting property, that is, if I know Z transform of un, I can guess Z transform of un plus 1. This is z into u bar of z minus u naught. When we derived it, I told you how many terms are there, we will subtract that. Z transform of un plus 2 is z square u bar of z minus u naught minus u1 z bar minus 1. Soon we will be solving problems based on these shifting property, that is left shifting as well as right shifting, and this is the frequently used shifting rule in most of the problems. And see this problem, if they ask us to find z transform of n plus 1 the whole square. So here we can expand it. This is easy for us. N square plus 2n plus 1. So z transform first term plus 2 into z transform second term plus z transform third term. So whatever formula we have seen, z transform of n square, we have used it. This is a formula for n. This is a formula for z transform of one piece of the tabular column, right? Just take LCM and simplify it. So it's like though we don't have direct formula for this, we are bringing it to the formula format and we are solving it. Now let's solve one more problem by using this shifting rule, that is show that z transform of 1 by n factorial is e power 1 by z, and hence find z transform of 1 by n plus 1 factorial and z transform of 1 by n plus 2 factorial. So when they say hence find, then by using the first result we are going to guess these two. Okay, so first let us find z transform 1 by n factorial. We don't have any direct formula, so this is just a direct definition. We have to write it and we have to find it. So what is z transform of un summation n is equal to 0 to infinity un z power minus n. In the place of un, my function is 1 by n factorial. I have replaced it. Just since the summation is from 0 to infinity, put n is equal to 0. 1 by 0 factorial 1. Anything power 0 is also 1. So first term is 1. Second term is z power minus 1 by 1 factorial. Third term is z power minus 2 by 2 factorial, and so on. Okay. So the right hand side, if I replace z power minus 1 to some x, 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, it is nothing but our e power x formula, right? So in the place of x I have z power minus 1. So that is what we have written. Replace z power minus 1 by x. Now you can see the pattern. 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial. This is nothing but e power x. The place of x, again you replace it by z power minus 1. So e power z power minus 1. This is nothing but e power 1 by z. So we got z transform of 1 by n factorial. Okay. So now if I know z transform of 1 by n factorial, I can guess z transform of 1 by n plus 1 factorial. Just now we saw shifting rule. So what is the formula? Z transform of un plus 1 is equal to z into u bar of z minus u naught. If 1 is there, we will subtract 1 term. If 2 is there, we will subtract 2 terms. Keep this in mind as it is in the formula. So what are the first 2 terms? U naught is the first term. U1 by z, that is u1 z power minus 1 is the second term. So we have subtracted these 2 terms. So this is the formula for in this particular case, that is un plus 1 and un plus 2. So here un is 1 by n factorial. So what is u naught? First we will calculate u naught and then substitute. So 1 by 0 factorial, that is 1. What is u1? 1 by 1 factorial, that is 1. Now you know what is u naught, what is u1, just you have to substitute here. So z transform of un plus 1, that is the next term. What is the next term? 1 by n plus 1 factorial, that is equal to, see the formula z, u bar of z. U bar of z is your solution that you have got it. E power 1 by z, so we have written e power 1 by z minus u naught. Un is 1 by n factorial, u naught is a particular term, we got it as 1, substituted that. And second one is 1 by n plus 2 factorial, this is nothing but un plus 2, next to next term. So z into, we have written z, u bar of z, u bar of z is nothing but your solution, e power 1 by z minus u naught, just now we have derived u naught as 1, minus u1, u1 we got 1, z power minus 1, that's it. So we have solved problems by using shifting rule as well as z transform of cos n theta and sin n theta. So basically we have few formulas and we will be using those formulas to get the desired result. Thank you.